Hello students, welcome again for the third lecture of projection of solids. I am going to start with a problem based on pyramid. Now before we start, I would just quickly revise what we have done in the previous two lectures. Now this part was very important, right? Quickly revise some basics. Any point in the HP, front view lies on XY, HP is horizontal plane. Any point in the vertical plane, top view lies on the XY. This was covered in our first lecture of projection of solids. We're going to talk about a pyramid right now. Okay. Talking about a pyramid, we had already discussed a pyramid in our second lecture. Okay. Any pyramid is named in this way. The base, this is the square base. The square base is named as 1, 2, 3, 4. These are the base edges. 1, 2, 2, 3. Base corners 2, 3, 4. Axis OM. Slant triangular face O1, 2, O2, 3 and so on. Slant edges O3, O4, O1, O2. Okay, we're going to talk about a square pyramid. The reason is our problem here talks about a square pyramid. So I'll be keeping this for ready reference. Okay, fine. Now, let us first read the problem and understand what they are talking about. Okay, let's talk about a square pyramid. Parallel. Here. Now, the problem says something like this. We need to understand the problem. Okay, I had given some master points and master diagrams. We are going to make a good use of them today. Fine. See what the problem says. This is our first problem, page number 9. A square pyramid of 40 mm edge of base. Which is the base edge or edge of base? It is this 1, 2, 2, 3. So other words, they are trying to tell us that 40 mm is the length of 1, 2, 2, 3, 3, 4 or 4, 1. And 60 mm axis. Yes, that's correct. OM. This is the axis whose height is given as 60 mm. Now, they're talking about a square pyramid where the base edge is 40 mm in length and the axis is 60 mm. Okay, let me keep this aside and let me talk about the remaining part of the problem. See what they have written. Is resting on one of its corners. They're talking about a base corner. One of its corners in the HP, horizontal plane, with the axis, remember, OM, making an angle of 30 degrees with the HP and parallel to the VP, vertical plane. Draw the projections. Now, how do you approach this problem? Now, to go ahead, I would want to quickly revise some points that we had done before. Remember the important points. Solids are always kept in the first quadrant. Okay? Now, what is the meaning of first quadrant here? I would quickly want to draw this in 3D and make you understand. Let me draw the first quadrant for reference here. So, this is our first quadrant that we're talking about. I'm just going to draw this in 3 dimensions. We had done this in projection of points basically, where these, I explained how this is actually the first quadrant here. So I've just drawn the first quadrant where this is the vertical plane and this is the horizontal plane. This is what is the XY line, somewhere like this, that's the XY line, the intersection of the vertical plane and the horizontal plane. So now we are going to say that the solid is kept in this particular quadrant. Okay, this is first quadrant. It means that the front view is always going to be above and the top view is always going to be below. Okay, now so that you have a quick ready reference of what this is, I'm going to draw a quick fast three-dimensional view of the same. Look, this is what I'm talking about basically. Okay, and I'll show the first quadrant here. This. Here, I've drawn the two screens that we talked about in points. Here, like this. Okay. And here we go. This. And now, this is the quadrant system. Remember, which we had talked about in our previous chapter. This was the first quadrant. This is the VP and the HP. You're calling them as the first quadrant, but now this is just some space here, and the intersection of the VP and the HP will give us the XY line. This is what I have shown here. I've shown this region I've shown here. Okay, fine. So now they have mentioned that a square pyramid is resting on one of its corners in the HP. Now, very important, very important. Remember, I've said that the solids are always kept in the first quadrant, front view above and top view below. I'll come to this point when we actually draw. Now, the question is, they have mentioned that is resting on one of its corners in the HP. Now, guys, please listen, very important. Here, how to start with the problem? The first master point will tell us. Now, the first master point tells us that if the base corner, yes, the problem somewhere did talk about a corner. If the base corner is in the HP, yes, it was in the HP, assume the entire base in the HP. Once again, we read the problem properly. 40 mm edge of base, 60 mm axis we understood, is resting on one of its corners in the HP. The first master point did guide us about this. If the base corner is in HP, assume the entire base in HP. Now, if the entire base is assumed in HP, we are going to refer our first master diagram, which talked about the base in HP. You understood how this goes? Very simple. We read the problem carefully. Square pyramid is resting on one of its corners in the HP. Acha, but the first master point tells us that if the base corner is in the HP, assume the entire base in HP. And if we assume the entire base in HP, we should start with this master diagram. It means that our step number 1 is drawing the base. But we already know the base of a square pyramid is a square, which is named as 1, 2, 3 and 4. So now I am going to draw the step 1 of our problem, XY line, and below that step number 1 is drawing the base of a square pyramid. So now let us start drawing it. I'm going to use some color combinations so that you understand the thickness and darkness of all the lines. A blue color line or a blue color marker will denote a medium dark line, guys. This is a medium dark line. That's your XY line, right? Now, we are going to draw here step number 1. If you remember, just quick go through. This was step number 1, the base of the square pyramid, which is obviously a square. Now, even for drawing the square, there are many possibilities. We can tilt the square in any manner. Here, the second master diagram comes into picture. What does the second master diagram say? Whatever is kept in the HP, remember, our corner was kept in the HP. whatever is kept in the HP, place it to the right. It means that we need to place our corner on the right side. See, I'm going to go ahead with this. Okay, I'm going to draw I'm going to use a pencil for drawing a construction line. Okay, I'm going to draw a light construction line here. Going to mark any point on that, and then taking an angle of 45 degrees. I'm using some simple geometry since I don't have a protractor here. Here, I have taken, here, I have used a simple tan 45 ka concept. This and this, I have kept them equal, 1 centimeter and 1 centimeter. Hence, this angle turns out to be 45. And that is a property of a square. I know that the base of a square is made up of base edges whose length I know, 40 mm. So, I'm going to draw 40 mm here, right? Similarly, on this side, I'm going to take, say, 45 again. Okay, I'll just tell you what exactly I have done here. I have drawn two edges. Here, I'll just show. If you have a protractor, it is going to be very simple. You have to draw a construction line, and you have to take 45 from here. You have to take 45 degrees from here, like this. All right, I just erase this. Okay, you need not name it. Okay, fine. Now I am going to draw a diagonal which connects them. Okay, and here I'm going to draw this. This is something 2.8. Extend the same thing. Yeah. So that's a square pyramid. While construction, what you have to do is you have to take 45 degrees. You have to draw these lines equal to 40 mm. Then keep your compass, take this in your compass, and from here you draw an arc. From here you draw an arc. So you will have a square. Okay, I'm going to name this in this manner. Like this. And this is going to be OM. I'll tell you how exactly I have drawn and why. We'll talk about simultaneously in the 3D format here. Now, this is the way I had actually kept our solid. Remember, corner to the right. Okay, this was the way. Actually, I'll just draw it here. I'm just trying to show this in 3 dimension so that you will have a better idea about this. Okay, this is how I had kept. Just draw this. Okay, this is the way I actually drawn a square pyramid here. Just these are now and this is the imaginary axis, of course. Here. So let me call this point as, say, M, and this is O. This is the way we had named it. 1, 2, 3, and 4. Okay, this is the way we have kept this solid actually with the corner to the right. Okay, now look at this. If you see this from the top, okay, the top view here, you will see a square 1, 2, 3, 4, exactly like this. Look at the naming 1, 2, 3, 4, and with O and M as one single point here, just like this, O and M. Okay, so this is the top view of the pyramid. And as I had told you before, remember, solids are kept in the first quadrant, hence top view below and front view above. So how are we going to draw the front view of this? I'll just try and project this, okay? I'll just try and project this here so that we are able to see what the front view will look like. Yeah, I'm just going to do some projections here. So I'm projecting all these points, okay? And I'm going to try and understand how the front view of this solid may look like. So I just projected all the points onto the vertical plane, okay? So O, the front view becomes O dash, okay? Please remember this, all 3 points, all these 3, they're in one single line, okay? 1 becomes 1 dash here, 3 becomes 3 dash, and this particular point, okay, since I'm seeing this from the front, it will have 2 dash, 4 dash, and M dash as well. All I have to do is I have to connect this, and if you would see properly, okay, something like this, and I have this O dash, M dash. So that's the front view. I also connect the base here by a dark line so that, okay. So now this is how the front view is going to look. We are going to draw the exact same front view here. Now what we are going to do is, in this way, we are going to project the axis point. OM was the axis point above, a light construction line, and I'm going to measure the axis height as 60. So here I'll just measure, name the point here, mark the point here like this. Similarly, I'll project all these points onto the XY line. Remember, this 3 is going to be projected on the XY and is going to be called as 3 dash, because I'm going to draw the front view. The reason is here, it is on the XY. 1 dash is here. This is 2 dash, 4 dash. Okay, I'm also going to name this point as, say, M dash here, and this was my O dash point. Now, the boundary of any solid is always, any view here is always a dark line, an outline. So this is it. Also, please look at this carefully. I'm going to draw a dark line here. The reason is very simple. Actually, there are 3 lines or edges which are present, 2 edges and 1 imaginary line. O dash, 2 dash, the one which you are seeing from the front, O2. So O dash, 2 dash, the front view of that O2. Exactly behind O2 is OM, the center line. O dash, M dash, the front view of that center line. And then we would have another edge, O4, which is again present here, O dash, 4 dash. So actually in this front view, there are 3 lines which are overlapping with each other. And as we always know, when many lines overlap, you will always show the darker one. Obviously, O dash, 2 dash or O2 is the one which is seen from the front, is the darkest of all lines. Now this is what we call as the stage 1 of our problem. Okay, I'm going to quickly dimension these. It's very important that we dimension. I'm going to use a construction line here, and then an extension line here till here. I'm going to name them. Okay, I'm going to dimension this. I knew that the axis height was 60. Also, I know that the base edge here was 40. So here I'm going to name this as 40. Alright. So that's our stage 1. This is our stage 1. Now, it has nowhere related with the problem. The reason is we are still referring our master diagram. Our master diagram 1 is complete. If you just refer it more properly, you would see that our base step number 1 is drawn. Remember, corner was kept to the right because that was what was suggested by our second master diagram, master point, which said that whatever is kept in the HP, remember the corner was kept in the HP, place it to the right. Yes, we have kept this corner onto the right. Okay. Now, step 1 is drawn. Step 2 is the height. Yes, we have drawn that also. Now, we are going to go with step 3. Now, step 3 says that in the problem, we have to learn about some condition with HP. Now, let us read the problem and understand what is that condition with HP. What are they telling us to tilt or rotate? Now, they have mentioned that with the axis making an angle of 30 degree with the HP. Now, where is our axis? Remember, which step we have to tilt and copy? Step number 2. So now let us only focus on this step. Okay. So now they are trying to tell us that this is the axis. Remember, O dash M dash. O dash M dash has to be tilted at an angle of 30 degrees. O dash M dash has to be tilted at an angle of 30 degrees. Now, how do we achieve that is very simple. I'll give a small note here. I'll give you a small note. Remember, if axis has to be tilted at an angle of theta or phi, remember this is angle with HP and this is angle with VP, then incline the base of solid at 90 minus theta or 90 minus phi. I'll tell you how to proceed now. Remember, step number 3 is we are going to have some condition with HP. What I'm going to do is, since they have said that axis makes an angle of 30 degree with HP, axis makes an angle of 30 degree with HP, theta, then I'm going to incline the base. The base here is named as 1 dash, 2 dash, 4 dash and 3 dash. I'm going to incline that at an angle of 90 minus 30, that is 60. So what I'm going to do is, I'm going to take any point here on the XY, and I'm going to name it as say 3 dash. Remember, what we are going to do now is we are going to tilt this view to the right. Other words, we are going to tilt this solid onto the right. Why onto the right? Remember, that was our general point, important point. Solids are always tilted to the right. So if you would question, sir, why will not tilt this to the left? So we are just following a convention. Okay. So what we are going to do now is we are going to tilt this solid to the right. Now if we are going to tilt this to the right, the point which is going to be on the HP is 3. Alright. Other words, tilting this solid is equivalent to tilting this view, is what we are going to do here. We are going to tilt this entire view to the right. So the only point that will lie on the XY is 3 dash. Now, we are not going to look at 30. We are going to look at this point. We are going to incline the base at an angle of 60 degrees. 90 minus 30, that is 60. So I'm going to take some measurement here. Okay, I'm going to use some geometry. Let's take a one. And I'm taking a ratio of 2 centimeter here. Okay. I'm just drawing 60 degrees. Okay, I just measure the base here. But you can have a compass and then you can go ahead with the same. Since I don't have a compass, so this here is this is a 60 degree line at 60 degree. What I have just done is I have inclined the base 1 dash, 2 dash, 3 dash, 4 dash, this base at an angle of 60 degrees, because this is what the note says. Well, what I'm going to do is also I'm going to measure this here. Guys, if you have a compass, it will be much more faster. Okay, I'm going to mark a point here called as 2 dash, 4 dash, and also M dash. This is the point, and then I know that the axis is 60 mm, because all we are doing is we are copying this solid as it is here. Okay, now if you would have a compass, the fastest way would be very simple. All you have to do, remember I have marked this by doing some geometry here, but you need not follow this long cut. You can do a very simple method. Once you incline this at 60 degrees, all you have to do is you have to take 1 dash O dash in your compass, 1 dash O dash, cut an arc, 3 dash O dash in your compass, and cut an arc. You will get O dash. Okay, it's the fastest way you can go ahead with. And this is that edge in between. So I have actually copied the entire thing as it is. Now, a small point, always remember, since center line is always imaginary, always extend it a bit outside the solid. Okay, always extend it a bit outside the solid, because we would want to denote that it's an imaginary line. Now what I have done, now if you see more carefully, if I would just extend this center line actually ahead, okay, like this angle here, okay, this angle here, this angle is what we would name as theta. And remember, this was 30 degrees. Now we actually made use of a very important property, you can say. The solid was always a right rectangular solid. The axis was always going to be perpendicular to the base. Hence, if this is 90 degrees, this is 30 degree, this is going to be 60 degrees. Okay, that is what we have written here. Now we are going to, now basically by tilting this view, we have tilted the solid. Now, on tilting the solid, this is the way you're going to complete the top view. That is the final stage. I'm going to project all these points below. You can see I'm using a construction line, absolute light lines. Remember, construction lines, very important, they have to be absolutely light. And here I'm just projecting the top view points also. Okay, projecting the top view points also here, like this. I projected all the points from the top view, all the points from the front view as well, to complete this particular view. Now why, sir, why did we do this? Guys, it was very simple. I'll just show you. Say we're going to tilt this. So I'll just measure this somewhere around 4.4. I'll take some point, and here let us say that this is the view that we have tilted. Once again, this view we have tilted like this. Remember, the view is not tilted, the solid is actually tilted, okay, and hence the view also is tilted. Say let me just, okay, this is what happened. We tilted this view. This was O dash. Okay, I just named some points so that it will be easier for us to understand. This was 3 dash and this was 1 dash. I just marked 2 dash, 4 dash here. Okay, this was M dash. Okay, this is what happened. This, remember, this happened because we have tilted the solid. I'm not showing the tilted solid here because it would make the diagram a bit more complex. Now, if I would want to get this point, so this is what I have been doing. I have projected this, okay, projected this here, projected this point number 3 here, and I'm going to project this point here. The intersection of this is going to give me the actual point number 3. basically remember, all you can do is, this was our first step. It is not that we have lifted the solid and kept it here. We are tilting the solid right here in this place only. So instead of showing in the same thing, na, same alignment, I'm just showing the same thing here. Once I'm going to tilt this 3 ka front view is going to be this 3 dash. So alternately, for getting this point, all I had to do was just take the projection. This is what we are going to do here. So if you see this 3 dash and this 3, their intersection is going to be 3 here. Once again, 1 dash and 1, their intersection is going to be 1. 2 dash and 2 dash and 2 here. This is 4. Similarly, O dash and O, this is going to be O, and this is going to be M. Remember, this is the top view, so all numbers with no dashes, or all alphabets with no dashes. Now, to make this view, do not imagine. Please remember my words. Do not imagine. Follow a simple sequence. Okay, because it's fully logical. Now, we know that the boundary of any view is always dark. So without even thinking how the problem is going to start, or how this view is going to start, I'll just go on drawing the boundary as absolutely dark here, right here. Now, that's how I would start. I'm not thinking how this will be tilted. I'm not visualizing how it looks like. I'm just going with some basics, as I've told. Remember, in the first lecture itself, build your imagination. It takes time. Do not directly jump to it, because it is very dangerous. Okay. Yes. So let's come back. Sequence number 1 for making any view is you always make the boundary dark. The boundary are the extreme points. Okay. You connect them by an outline, a dark line. Now, after that, place the observer. Place the observer. Sir, how would you know the arrow is here? I did not tell this. The master diagram tells this. The master diagram tells that the arrow denotes the direction of the observer. This is our condition with HP. And this is how the observer is going to look. We are going to draw the corresponding top view. This is where we are. So now, as soon as I place the observer, what does the observer see? The observer sees O dash 1 dash. Okay, you can visualize this in this way. Try and pour some water. As soon as you pour some water, the water is going to splash on O dash 1 dash. It means that O1 is going to be visible here. That's O1 connected here. Now, once you complete this, is there anything that is going to be seen right from the top? No, that's it. You're just going to see the water is going to hit on O dash 1 dash. That's it. Okay, so we have connected this. Now, we have to complete this view. Okay. Now, for that, the final part is understanding the solid itself. Remember, what was O12? A slant triangular face. What was O14? Another slant triangular face. Now you can quickly see here. I'm going to just shade it a bit. And look at this was O12. This was O12. This was a slant triangular face. And very adjacent to it, I have O14. I have O14. Now, O12 and O14 are actually the adjacent faces. So, these two faces are covering up the view. They have covered up the entire view. It is like, you can just imagine that you have painted this face or plane with a black color. So, are you or would you be able to see what is inside this plane? No, it would be hidden. And hence, we are going to connect 3, 4 by a hidden line. Same here, a hidden line like this. Okay, OM should also be connected. Why did we connect 2, 3 and 3, 4? Because they would make up the base edges. Alright, we are supposed to connect OM also, but OM is a center line. A center line is lighter than the outline. Hence, we have not shown the center line. But as I have said, we just extend it a bit outside here. Okay. Now this is, I just name this the front view and the top view. We'll just quickly mention somewhere aside that theta was 30 degrees. It's 30 degrees was given in the problem. Okay, so there lies the entire problem of solid for a square pyramid. I hope you have understood. Next problem, we are going to start with a pentagonal pyramid. So I will draw a similar 3D so that you can understand how exactly it happens. Now please, a quick note. देखो, you are actually supposed to think about how it is going to be tilted and what will be seen and all, but it will take a lot amount of time. The master diagrams and the master points that I have given are giving you a ready reference of how to finish the problem faster. Definitely, we are going to build our imagination. Okay, have a look at this solid. It is very simple. If you would tilt this, O1 is going to be seen from above. Because this was that O1 edge. O12 and O14 were going to be slanting once you would tilt this. This is O12 and O14. So you're going to build that imagination slowly. It will take some time. Follow the master diagram and the master points for now. Thank you. Thanks a lot.